Okay, so here's very quick primer on eigenvectors and eigenvalues before we do some examples. All right, so we're looking at the equation ax equals lambda x. This is the basis of the definitions. Okay, x. If there is a lambda, so that when you multiply a times a vector, you get a constant multiple of that same vector, then x is called an eigenvector, and the lambda is the eigenvalue. Okay. This is really similar to solving for a steady state vector. It's just that in the steady state vector equation, you're solving, what is lambda? 1. Yeah, you're solving for, your stochastic matrix times x gives you the same x back, right? So this is equivalent to solving a minus lambda I times x equals 0. And now it looks more like the equation that you've been solving for the steady state. It's just instead of plain old I, it's lambda I. Okay, let's look at some examples. So I have a matrix A, and I want to know, is 1, 3 an eigenvector? Okay. So for it to be an eigenvector, A times that vector has to be a multiple of that vector, a constant multiple of that vector. So let's see what happens when I multiply, is AX equal to lambda X? Okay, so AX would be 1, -1, 6, -4 times 1, 3. And you can put it in your calculator or just do this out in your head, and you get -2, -6. Okay. Is -2, -6 a constant multiple of 1, 3? Yeah, that is -2 times your original vector 1, 3. That is the definition of being an eigenvector. If when you multiply your matrix times the vector, you get a constant multiple, a scalar multiple of the vector back, then that is a eigenvector. Yes, okay. So if 1, 3 is an eigenvector, what is its corresponding eigenvalue? -2. It's the multiple, yeah. So I could ask the question in a different order, right? In this one, I gave you a vector and said, is it an eigenvector? Now I'm going to give you a scalar and say, is it an eigenvalue? So we do the same thing, right? So I need to know if does AX equal 3x, right? AX equals lambda x. That's the definition of eigenvalue, eigenvector. I put in a 3 for the lambda. And now I just need to say, is there an x? Is there a vector x that makes this true, right? So I need to solve this. So I'm going to solve it instead by ax minus 3x equals 0. And so I'm going to solve a minus 3I times x equals 0. This is the same equation you've been solving to find steady state vectors, except instead of a minus I, now it's a minus 3I. All right, so a minus 3I. So a is 3, 2, 0, 1. 3 times the identity is 3, 0, 0, 3. Times some unknown x, x1, x2, equals 0, 0. So this becomes 0, 0, 2, -2. We're going to augment it with 0, zeros and row reduce. And you get 1, 0, -1, 0, 0, 0. All right. So what does this mean? What's my solution? Yep. So no, actually, x1 and x2 are the same. Yep. and x2 is free. Right, so there are infinite solutions to this. So x1 equals x2, x2 is free. So that means there are infinite vectors x1, x2 that make this true, ax equals 3x. So 3 definitely is an eigenvalue because you can solve this thing. There is an x, right? So this is a yes because there's a solution. And there are infinite eigenvectors that correspond to that eigenvalue. Okay. So that is called the eigenspace. The eigenspace is all of the eigenvectors that correspond to a given eigenvalue. So, sure. You row reduce and you get a contradiction like 0 equals 5. Right, but you could definitely have like a 5 here. Yeah. Or here. So that this would say, oh, but that would, oh, I see what you're saying. There's only 0 on the other side, so it could never be like 0 equals a number. Oh, okay. It could be that the only solution is 0. It could be that the only solution is the trivial solution, and by definition, from the reading, we never count 0 as an eigenvector. So if there is only the trivial solution, then you say that there isn't an eigen, that 3 is not an eigenvalue. There's no eigenvector associated with it. That was a good question. Yeah. Yeah, if 0, no, not zeroed out, but if it was 1, 0, 0, 1, so x1 equals 0, x2 equals 0, you have only the trivial solution. Yeah. Then you would say that 3 is not an eigenvalue. Thank you. I didn't even really think that through. Okay, so eigenspace, that is the set of all eigenvectors associated with a given lambda. Right? So for our case, for lambda equals 3, I want to describe all the eigenvectors that go with that lambda. And in that case, it's just x1 equals x2. It's all the vectors where the 2 entries are the same. So we can describe that in a couple of ways, right? We could say it is the set of all vectors that look like this, such that A is a real number. Set of all vectors that look like A, 2 entries are the same. Or we could say it's the span of what? 1, 1. Or I could say, or I could give a basis. For the eigenspace is 1, 1. So you can take your pick. I believe like on quizzes and tests, I say something like, describe the eigenspace in an appropriate way. And you can do any of these 3. All right, so that's it. This next thing, we're just not going to do this. Forget it. You can go on to the activities. Except in the activities, I want you to change the order of the problems. I want you to do 3, 4, 1, 2, 6.